Okay, let's go ahead and start. So today we're going to talk about a few things. We're going to talk about exponential functions, and we're going to talk about interest. Okay, so today's lecture is going to be all about exponential growth and exponential decay, which is useful in a business setting to model all sorts of financial situations, such as interest on a loan, or interest at the bank, or depreciation in value of some asset, or something like that. And we're also going to learn how to actually find the equation of an exponential function given 2 points. And I think that'll be about all we do today. Like last time, I think I'm gonna skip problem 3, and we'll come back to problem 3 if we have time at the end. Okay, so let's talk about problem A, the warm-up problem. And we're going to answer A, B, and C all at the same time using a table. Okay, so the table that I'm going to make, one column is going to be T, one column is going to be A of T, and one column is going to be B of T. Okay, so let's make our table. Where I'm going to say that T is going to be the time in years, and A of T is going to represent the amount of money I have in my bank account if I choose bank A after T years. Okay, so T should start with 0, then we'll have 1. This T equals 1 means exactly 1 year has passed. T equals 2 means 2 years have passed. T equals 3 means 3 years have passed. Okay, so initially I have $100 to deposit into my savings account. Okay, so neither of the banks are going to start giving me interest until 1 year has passed. Okay, so A of 0 is just going to be 100, same as B of 0 is 100. If I know how much money I have in bank A at some year, it might not be year 0, how do I find out how much I have next year? Should this be a linear relationship or something more complicated? For bank A, I'm talking about they will deposit an additional $10 per year into your account. It's bank A. What do we think? Kevin?
For bank A, it's going to be linear.
Yeah, it's going to be linear. And how do I find A of 1?
Well, it's telling you that you're going to put $10 in every year. So.
Exactly. Yep, we're just going to put $10 in, so we get 100 plus 10 equals 110. All right, the next year, they do the exact same thing again. So 110 plus 10 equals 120. Next year, they do the exact same thing, 120. They take the amount that we had, and they just add 10 to it. Okay, pretty good bank. If you make 30 bucks in interest in 3 years, that's quite nice. Okay, how about B of T? Does anybody want to try B of T? Let's highlight. What's the rule for B of T? They will increase my balance by 10% per year. That's what's going on with B. Yasmin? Yep, exactly. So do you know how I'm going to go from B of 0 to B of 1? Instead of 100 times 10%. Okay. Exactly. Okay, so what bank B does, it takes our current balance and adds 10% of current balance. So, for example, we take 100 and we're going to add, how do I get 10% of 100? Yeah, 0.1. 0.10 times 100. Okay? Now if I look at this here, I can take out a common factor from both of these two terms here. I've got 100 here and I've got 100 here. I can take out a GCF and I can write this as 100 times 1 plus 0.10. In other words, 100 times 1.1. Okay, so the way that I find my balance for the next year is I take my previous year's balance and I multiply by 1.1. So instead of taking my balance each year and adding a fixed number, I'm going to take my balance each year and multiply by a fixed number. This is exactly what it means for our growth to be exponential. Okay, so we take 100 times 1.1, we get 110. So first year they were pretty much even. Next year we take 110 times 1.1. We get $121, so we're $1 ahead. The next year, 110 times, not 110, excuse me, it should be 121 times 1.1. And we get some decimal, 133.1. So now we're $3.10 ahead, okay? You can imagine as we go on and continue on that this difference between A and B is just going to keep getting larger and larger because we're doing the exact same thing to bank A every time, but each time we compound our interest for B, we gain a little bit more because we're earning interest on our interest. Okay, so which bank should we use? Yeah, bank B, pretty much no matter what. There are some cases where maybe a linear function is going to beat the exponential for a while, but then the exponential will always, in the end, surpass it. It's just a question of how long it's going to take. Okay, so we should use bank B. Okay. All right. Any questions about the warm-up problem? Cool. All right, let's get into the definition of an exponential function. Okay, so P is an exponential function. Exponential function. And we're going to say of t. Of t. If we can write P of t equals P0 times A to the power t. Okay, so let's break that down a little bit. P0 is defined to be, that's what I mean when I write this little colon equals, I mean is defined to be initial quantity. Okay, so sometimes for exponential functions we're talking about money growing or population growing. So P0 represents my initial investment or the population at time 0. Okay, so P0 is just how we write our initial quantity. Okay, then A is defined to be the factor by which P increases when t increases by 1. Okay, so if 1 year passes, we take the quantity we had before and we multiply by a. If 3 years pass, we take the quantity we had before, multiply by a again, multiply by a third time. Okay, so for each year that passes, we just multiply by our factor. Okay, importantly, if we have 0 less than a less than 1, this means we have exponential decay. Okay, when I say decay, I mean that when we multiply by a number less than 1, our initial value is going to decrease each time. Okay? If a is bigger than 1, then we have exponential growth. Okay? You'll notice that I kind of left out the case where a is actually equal to 1. That's because if a is equal to 1, then each time we take our initial value, we just multiply by 1, by 1, by 1, by 1, and nothing is changing. Okay, so we don't have growth or decay. That would just be a constant function. Okay. So one more thing that I want to write down in this box, and that is a is equal to 1 plus r, okay, where r is our percent increase or decrease expressed as a decimal, okay? So where r is percent change as a decimal. So, let me zoom in here. I'm going to do a couple examples. Example, 5% interest at the bank manifests as r equals 0.05. This implies a equals 1.05. Okay? That's exactly how we did it in the warm-up problem. Okay? We had 10% interest. So each time we multiply our current balance by 1.1. Okay? R here stands for interest rate. Okay? So rate of growth, which we express as this percentage. Okay. Let me add one more page in here because I want to talk about why it's like that. Okay. So if we have 5% interest, we say 5%. Who knows what cent is the Latin prefix for? Anybody do word within the word? Sam?
Does it mean 100?
It means 100. Yes, a cent is 100, right? 1 cent is 1/100th of a dollar, right? So this means 5 over 100 equals 0.05. Okay. 6% decrease each year manifests as -6 over 100 equals -0.06. Okay, so if we have a decrease, then that's going to have our R being negative. Okay. Let me move all of this. down a little bit. Okay, so let's do problem number 1 together. A new restaurant just opened. The table below gives us some values for f of t, the number of customers on day t. Could f of t be exponential? Why or why not? Okay, so before, what we were doing was we were taking these tables and we were checking to see if the rate of change was the same between all of the different points. And we said if the rate of change is exactly the same between all of these points, then it's linear. So we want to come up with a way to figure out whether or not this is exponential, okay? So instead of trying to make sure that the rate of change is constant, we want to make sure that the factor by which we are increasing is constant. So what do I mean by that? We should have f of 2 equals f of 1 times a, and f of 3 equals f of 2 times a, and f of 4 equals f of 3 times a. Okay? So what we're going to check here is whether or not a remains consistent between all of our data points. Okay, so the way I'm going to do this is, here I can see, okay, what I'm going to do is I'm going to take this equation and I'm going to solve for a. And I'm going to take this equation and solve for a. And I'm going to take this equation and solve for a. And I'm going to verify whether or not each of them are equal. Okay, so let's do it one by one. F of 2, if I divide both sides of my first equation here, which is highlighted in red, if I divide both sides by f of 1, I get f of 2 over f of 1 equals a. A is kind of what I want to know here. So f of 2 over f of 1, that's going to be 18 over 14. Okay, in other words, 9 over 7. Okay, let's try the second one. It's too close in color. Let's try the second one. Okay, f of 3, if I want to get a by itself, this time I'm going to divide by f of 2 over f of 2 equals, now what's that going to be? 24 over 18. I think we can divide both of those by 6, so we get 4 over 3. Okay, now my question can be rephrased as, is 9 over 7 equal to 4 over 3? And what do we think? No, they're not equal to each other, okay? All right, so what we have shown is that to get from this number to this number, I multiply, geez, that's way too thick. Let's go right then. We multiply by, not 18, 9/7. Now to get from this number to this number, we multiply by 4/3. Okay? So, since our factor changed, we cannot express this equation in the form P of t equals P naught A to the power t, okay? Because A is not the same between each interval. Any questions about problem number 1? Okay, moving right along then. We'll do problem number 2 together. I'm going to do this one a little bit faster. And we're going to go back to the thicker pen. Okay, Mildred collects hats. In 2014, she began with 25 hats. All right, right off the bat, that tells me that my initial value is going to be 25. Okay, so we want to write h of t equals h naught times a to the power t. We've immediately been given h naught is 25. Okay? She plans to increase her collection by 25% each year. Okay, that's another key piece of information. Increase by 25% each year. What's that telling me? That's telling me that R equals 0.25. If R is 0.25, what's A? 1.25. We just add 1 to it. Okay, so we've already got all the pieces. Let me guess, it's going to ask us to come up with a formula for the number of hats that Mildred will have 10 years after 2014. Okay, so we write a formula for h of t. We already got h naught, we got a. We can write h of t equals 25 times 1.25 to the power t. Now, they ask us, how large will her collection be in 2020? If t equals 0 corresponds to 2014, what value of t corresponds to 2020? Yeah, Abhi? 6. That's exactly right. So, how do I find that? T equals, how do I want to write this? Okay, let's just say 2020 minus 2014, right? Where this is our starting year. Equals 6. So, the number of hats in 2020 equals h of 6 equals 25 times 1.25 to the power 6. So you could type that in on your calculator and multiply it out and you'll get something which I wrote down. Where did I write it down? 95 hats. Okay. So pretty standard example. They gave us h naught right away. They gave us r. We had to do a little bit of work to find a, just had to add 1. We put our formula together. And then we figured out how many years there were between 2020 and 2014. Any questions about problem 2? Okay, I'm going to move on. All right, we're going to talk about interest now. Okay, so when you see a problem say annual interest rate, what they're talking about is the value R, which governs the equation p naught times 1 plus r to the power t, where remember 1 plus r is just a. Okay? Where t is number of years. Okay, so t equals 1 corresponds to 1 year after we started our investment or our loan. Okay? That's annual interest rate. We'll also talk about monthly interest rate. It's the same thing. It's the value r dot 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 dot, where t is number of months. Okay, so we use the exact same equation. We're just changing our frame of reference with t. If we're talking about monthly interest or daily interest or semi-annual interest. Okay, those are the definitions of our interest rates. Okay, let's do problem 4. It's another bank problem. Okay, so suppose an investment of $800 earns 7% interest per year. Come up with a formula for how much money you will have in t years. Okay, so we want P of t equals P naught times a to the power t. This is what we want. Who can tell me one piece of information that's given to me by the problem? Anyone besides Abit and Yasmin?
Use 0 be 100.
That's exactly right. Alice, you want to tell me the other piece of information that's given?
R is 0.07, so A is 1.07.
Perfect. Okay, so P of t is equal to 800 times 1.07 to the power t. Sweet. Thank you both for your contributions. Anyone have any questions about that problem? That's all they ask us to do. They don't even ask us to find our amount of money later on. Okay. We'll do problem number 5, and we'll do this last part here. I'm gonna keep an eye on my time here. All right, your boss proposes 2 different plans for giving raises. Suppose you currently earn $35,000 per year. In the first plan, you earn an additional $1,000 each year. In the second plan, you increase your salary by 3% each year. Which plan do you think is better? And check your guess by computing your salary after 5 years and after 10 years under both plans. Okay, so we should come up with a formula for, let's call this green one first plan, earn an additional 1,000 each year. We'll call green plan A. And we'll call red plan B. Second plan, increase our salary by 3% each year. Okay, one of these plans is linear and one of them's exponential. Which one's which? Yep.
Plan A is linear and plan B is exponential.
Thank you, Sam. Plan A is linear and plan B is exponential. Who can give me a formula for A of t? It should be a linear formula. Yeah, Uriel?
1,000 plus 35x.
1,000 plus 35x. We're close. I think we got the variable attached to the wrong number here. So we're earning an additional 1,000 each year, which means that as t is increasing, we should be multiplying t by this number here, 1,000. So I think we should have 1,000t plus what's our initial salary? 35,000. Okay, so we got this linear formula here. All right. Remember, what we called these things were our fixed salary and our variable salary. Okay, so fixed versus variable. Fixed is going to correspond to our initial salary, and variable is going to correspond to how much I'm going up each year. So that's why I want to attach it to t. All right, somebody want to try for plan B? Yes, Mary.
You do P of T equals 35,000 times 1.03.
Exactly. Okay, perfect. So the problem told us that our increase was 3% each year. That told us that R should be 0.03. We know from our definition about A that A should be 1 plus R, so we get A equals 1.03. That's how we come up with that formula. Okay. Before we compute these things, which one do we think is going to be better in the long run? Probably B. Probably B. Okay, let's try. So we did that. Let's try computing A of 5. Well, that's just going to be 1,000 times 5 is 5,000 plus 35,000 equals 40K. How about B of 5? Well, we're going to do 35,000 times 1.03 to the power 5. And that comes out to kind of ugly number. We get $40,574.59. Okay, so plan B is already ahead. And what we know about exponential functions is that they're just going to keep growing faster and faster and faster. So if we're already growing faster, we can expect that after 10 years, we're going to be doing even better in terms of the difference between these two plans. A of 10 is just going to be 10,000 plus 35,000 equals 45K. That's our salary. B of 10 is going to be equal to 35,000 times 1.03 to the power 10. And if we type that in on our calculator and multiply it out, we get 47,037.07. Okay, so after 5 years, under Plan B, we were making, our salary was $574 better. After 10 years, our salary was $2,037 better. Okay, so what I'm trying to point out here is that the gap just keeps getting greater and greater. That's because if we were to graph these two functions, A would just look like a line. Here's A. What would B look like? Well, it looks something like this. Okay, let me draw it like this, maybe. That's what B looks like. So as we go along, our reds here, red, 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 this distance here is getting larger and larger as we go along. Okay, so they're gonna kind of separate like that. All right, that's the power of exponential growth. Any questions about problem number 5? About figuring out these formulas or about plugging in? I think the harder part is figuring out the formula, and then plugging in is mostly just use the calculator. Okay. 10:17, we got 13 minutes. All right, I'm on time for once. So, we want to find the equation of an exponential function given 2 points. So, they give us t1 and f of t1 and t2 comma f of t2. And they ask us to find f of t equals, how do I want to write it? f0 times a to the power t. Okay, that's what they tell us. I'm going to add in a page here because it's going to take me a second to write down how we do this. Page 3, add page. Whoops, that was not the right page. This is the right page. Whoa, I'm lost. Okay, here I am. All right. So the way that we're going to do this is first by finding a, and then by finding f0. Okay? So we know that f of t2, we can get this number by taking f of t1 and multiplying by a to some power. Anybody want to guess what the power should be? Should it be 1? Should it be something more complicated? What do you think? Sensing some hesitancy. Okay, say for example we had 0, 3 and 3, 10. Well, between these 2 times, 3 years have passed. So how many times do I need to multiply by my factor? 3 times. The way I got 3 was I took this one and I subtracted this one. So what's going to go in the power on a is going to be t2 minus t1. Okay, so this equation right here is going to allow us to figure out what a is. Okay, so we just want to find out what a is, so we take f of t2 divide by f of t1, and that's going to be equal to a to the power t2 minus t1. Now the way that I get a by itself, I have to undo a power. What undoes powers? Square roots, or more specifically, nth roots, right? We're going to take everything on this side and on this side to the same power. The power is going to be 1 over t2 minus t1. Because when I multiply these powers, remember if we have a power to a power, we multiply the powers. If I multiply them here, I'm going to get just a to the power 1 on this side. And on this side, I'm going to get f of t2 over f of t1 all to the power 1 over t2 minus t1. All right, so that's how I figure out what a is going to be. Okay, so you can just memorize this formula if you want, but I kind of recommend just remembering that this should be true. This f of t2 equals f of t1 times a to this power, that is something that's relatively intuitive, I think. It's how do we get our money later depending on what our money is now, okay? If you know this equation and you know algebra, then you don't need to memorize this bottom one, but if you want to, you can memorize the bottom one. Okay, now how do we find f0? Right, we have a now, and we want to figure out what is f0. Well, if we know a, what we can do is just look at the point t1 comma f of t1. We're going to examine this point. What this means is that if we take f of t1, it's going to be equal to, not p, f0 times a to the power t1. Right? That's how we get f of t1 using our formula. And guess what? This side right here, f of t1 is known. t1 is known. A, we just found out from the previous step. So we have an equation here where f0 is the only thing we don't know, so we can just rearrange it. So what do? We divide both sides by a to the power t1. And we get f0 equals f of t1 divided by a to the power t1. Okay, things are starting to heat up a little bit in terms of how abstract this all is. So let me do an example and then we'll take questions. Oh, sorry, is anyone still writing? We're good to do the example? Okay, I can't keep them both on the screen at the same time, sorry. Okay, so we want to write an equation for each of these exponential functions whose graphs are shown below. Let's start with this one. What are my 2 points that I'm given? Someone tell me one of my points. Yep, 0, 100 is one of my points. What's my other point?
3, 21.6.
That's right, 3, 21.6. Okay, now, I know how to get 21.6 from 100. I know that 21.6 is going to be equal to my initial investment, or my loan in this case, since we're decreasing in value. It's going to be my initial value times a to what power? The power should be the difference in time. Yeah, the difference in time here is 3. I went from time t equals 0 to time t equals 3. Okay, so a to the, well, in this case we've got y and x. So I'm going to do x here. Okay, so I want to figure out, sorry, not x. Should be 3. A to the power 3. Okay. I want to figure out what a is, so I'm just going to rearrange this equation. A cubed equals 21.6 divided by 100, that's 0.216. So a is equal to the cube root of 0.216, also known as 0.216 to the power 1/3. What's that equal to? Anybody know? 216 is what number cubed? You guys don't memorize your cubes, huh? Guess that's just me. Okay, it's 6 cubed, so this is going to be 0.6. We multiply 0.6 times 0.6, we get 30.36. And we multiply by 0.6 once more, We get 0.216. Okay? You can just use a calculator if you want. Okay, so that's A. What's P naught? What do we think P naught is equal to? Yeah, Kevin? Yeah, 100. P naught is, well, okay. I should really write Y naught because that's given to us up here. We have Y and X axes, so we'll use Y and X. So in our case, Y naught is equal to 100. Okay, that's the value of Y when X is equal to 0. So Y of t equals Y naught times, and I used t again, excuse me, this should be Y of x equals Y naught times a to the power x. We figured out Y naught and we figured out a, so we can write Y of x equals 100 times 0.6 to the power x. That is our final answer. Okay, so let me reiterate what we did here. Our first step was to set up this equation, which I'll highlight in green. This is kind of our intuitive basis for what's going on here. We say, okay, our money at time t equals 3 is going to be our initial money, and we multiply by our factor 3 times. A times A times A, that's A cubed. And now I have an equation with just one unknown. So I just rearrange, I divide on both sides, then I take the cube root to find A. Once I know A, and only once I know A, can I compute P naught. In this situation, we were able to read P naught directly from the graph, so that was kind of convenient. But in general, what we'll need to do is this second part here, where we take f naught to be equal to f of t1 divided by a to the power t1. In general, that's what we're going to need to do. Are there any questions about this problem number 6? Okay. If you have further questions or you want to see some extra examples, then you can stay after class and I'll do a couple more. Otherwise, today's lecture is over. Just a reminder, you guys have a homework due on this Friday. I think it's due at 11:59 p.m. on Friday. And also, don't forget to be doing your exit slips within 1 week of viewing the lecture, however you want to do that, whether you do it online or in person.
Actually, I have a question.
Mm-hmm.
Okay, so I'm a transfer student from Appalachian State.
Okay.
And so I took like kind of a business calc, but it wasn't the same one like that Darla Morney did, so I'm taking another one.
Mm-hmm.
And when I remember when we used to do it, do y'all have like a different way you do like other equation that's like this? Because I feel like, well, maybe I put it on the other one. Sorry.
Okay, that's all right.
Like, because I haven't like seen the one equation that you've done before, but like I feel like I've seen like versions of it that are like very similar.
Yeah, you might have seen something like, you might have seen something like p times e to the t.
Oh, okay.
Okay, so in this scenario, e is the number 2.718, whatever, that constant, right? So this is one way that you can think about exponential growth. The reason that we do it this way in class is, in general, you can express any exponential growth using this formula, but it's convenient for the purposes of computing financial mathematics to use just any number here. So when I write a, sometimes a is going to be e. But sometimes A might be something like what we did in class today, 1.1, if that's talking about like how our interest is multiplying over time.
Okay, so they are different. Like still.
Yes, they are different in when I write PA to the power T, A is some number, which we might not know.
Right.
In this case, E is 2.718 dot dot dot. Some number which is known, okay? If we do it like this, we have to be careful about what's in our exponent. The way that we're gonna make these two things reconcile is by putting an R here, where R is gonna be some other variable. So there's two ways of doing it. We can do it this way, where we have to focus on figuring out what R is, or we can do it this way, where we have to figure out what A is. That's all that there really is. So so the only difference between these two things is that A equals E to the power R.
Okay, cool.
Okay.
All right. I was like, they look so familiar, but like,
yeah,
it's not quite the one I thought it was.
Slightly different notation.
Okay, cool. Awesome. Thank you.
Yep, no problem.
I have a quick question about a homework problem.
Okay, sure.
Yeah.
Do you want to do it after class?
Sure.
Does anybody have an administrative question?
No.
Homework question as well?
Yeah.
Alice?
It's the same.
Oh, same question. Okay. So you guys are all sticking around then? Okay, then let me see the problem.
Is it the following?
All right. Let's get an extra sheet here. Okay. So a company's pricing schedule is designed to encourage large orders. Okay, so if we order more, we get a discount in terms of price per dozen. We're supposed to find a formula for Q as a linear function of P and find a formula for P as a linear function of Q. Okay, so we have a table, and I'll just fill it out real quick, and then I'll give you your notebook back. Q and P, we've got 3, 4, 5, and 6, 14, 12, 10, and 8. Okay.
Thank you.
So we want to find a formula for Q as a function of P, and we want to find a formula for P as a function of Q. Okay, so let's start with the first one. If Q is a function of P, which one's my input, Q or P?
Q?
So
P.
it's gonna be P, and here's what I'll write. If we see something like F, and then we see is a function of, or varies according to, or depends on, and let me switch my letter here. We'll use S. And then I get T. What these things all signal is these words precede the input variable. Okay, so if I hear is a function of T, that means that T is going to be my input. If they say S depends on T, what they mean is that S is the dependent variable and T is the independent variable. In other words, T is the input. Okay, so if you see words like this, those are going to go right before our thing. There's another one, is determined by. Stuff like this. That's our cue that we're about to hear what the input should be. Okay, so in our case, we have q as a function of p, so p should be the input. So what I want to find is q of p equals m times p plus b. This is the equation that I want to solve. We did this one in office hours the other day, right? Or were you in office? Maybe I'm... Or maybe that was with you.
I remember I asked that from.
Okay, yeah. You guys, I think you both came to office hours that day. Yeah. But I got the problems mixed up. Okay, so this is what we want to write, okay? So we want to figure out what m is. Remember, m is going to be the difference in output divided by the difference in input. So what I'm going to write is q of p2 minus q of p1 divided by p2 minus p1, okay? On the bottom I've got change in input, on the top I've got change in output. Okay, so the way we figure out what all these numbers are is just by reading them from the table. We can choose any 2 points that we want. Let's take these ones, okay? So we'll have P2 be 12 and P1 be 14, okay? So m is equal to q of P2 is 4 minus 3 divided by P2 minus P1 is going to be 12 minus 14. So we get 1 over negative 2 equals negative 1/2. So that's m. All right, so now I've got q of p equals negative 1/2 times p plus b. How am I going to get b? Any ideas? We could use point slope, or there's one other thing that we could do. The way we did these in class the other day was by just taking one of these green points here and plugging it in. If I was to plug in the point 3, or 14 comma 3, really, how should it go into this equation? I should have negative 1/2 times, what should go in these parentheses here? 14. And what should go on the left-hand side? 3. Plus b. Now we just solve this for b, okay? So 1 second, and let me move all of that way down. And then let me move this part down a little bit so we have room to solve. Okay, so we want to figure out what b is. This means that 3 equals negative 7 plus b. So we add 7 to the other side, b equals 10. So our final equation is q of p equals m. We computed over here, it's negative 1/2 times p plus our intercept was 10. So I put 10, and that is my final answer. Okay, feel good about that one? Okay, let's do another practice. Find a formula for p as a function of q. Okay, we can use the same 2 points now, except now instead of doing q of p, we're doing p of q, because we see p as a function of q. That means that q should be the input. So now we're going to figure out p of q equals m times q plus b. All right? In this case, our m is going to be, again, change in output divided by change in input. So I'm going to write p of q2 minus p of q1 divided by q2 minus q1. So if these 2 green points are my points again, what should go on top of my fraction here?
12 minus 14
That's right.
Over 4 minus 3.
And that is equal to negative 2. All right, so we know now P of Q equals negative 2Q plus B. And now we're just going to take either of these 2 points or any other point if we want. Why don't we use this, this one that I'm highlighting in red this time? We'll use 5 and 10. We can just use whatever point we want. All right, so P is going to be 10 equals negative 2 times
Times
5 plus B. So we get 10 equals negative 10 plus B. Add 10 to both sides. We get 20 equals B. So now we have M and we have B, so we can write P of Q equals negative 2 Q plus 20. All set.
Yeah, thank you.
Do you have any lingering questions about that?
I think I must have just made some slight error.
Yeah, I think a lot of students are confused about what should be the input and output when my letters aren't F and X. When it's F and X, it's like, okay, yeah, X is the input, F is the output. But when we get P and Q or S and T, then it's suddenly like, I'm not so sure. So when they try to make you find both, then it just kind of like gets people confused about how to write things. Okay.
Thank you so much.
Yep, no problem. Any other questions, or do you guys want to see more from this lecture?
Should we do a problem where we have to find that F of 0? Like the last one we did not do that second step.
Yeah, because we just got to read it from the graph. Okay,
Yeah.
we'll do another one of those. Can you remind me of your name again? I forgot. Thomas, right? That's right. Duh. I thought maybe it was Tanner, but then I was like, no, Tanner's back there. Okay. Wah. I wonder if I can. Do you think I can cut things from the picture? Oh wait, copy. Oh my god, this is going to be so incredible if this works. Oh, beautiful. Wow, okay, that is opening my horizons. Okay, didn't copy exactly right. This was negative 2, and this is 1. Okay, so first, tell me what our 2 points are.
Negative 2, 9.5, and what, 1.5?
Yep. Okay. So, is step 1, so we want to write y equals y naught times a to the power x. So, what comes first? Find a or find y naught?
Find A.
Find a. How do I find a? Does anybody want to walk me through it?
You subtract 0.5 from 9.5.
Subtract 0.5 from 9.5. We would get 9. What do we think? 9? 9 would correspond to the change. That's what we would want to do if we were working with a linear equation. Remember, linear is all about adding and subtracting, and
Or so we'd
exponential is more about multiplying and dividing.
So we'd set 9.5 equal 2.5 times A to times 100.
Where's 100 coming from?
I don't know. Would it be 3?
So we want to figure out what a is here, or what the power is on a, and it should be 3, but this isn't quite right. This would be right if we started at 0.5 and we ended at 9.5. our starting value was 9.5, right? So this is almost right. We should have 9.5 times a cubed equals 0.5, okay? 9.5 is our starting value. So we multiply by a to get this value, multiply by a to get this value, multiply by a to get that value. Yeah.
Just do the starting value equals the ending value, or you do the starting value to times a to like the difference in the x's.
Yep.
Equals the ending value.
Exactly. Yep, that's exactly what we wrote up here. So what I wrote it in is kind of general notation here. I said f of t2, let me highlight with green. F of t2, that's our ending value, equals our starting value times a to the difference in time. That's exactly right. The way we wrote it down at the bottom is with one of these things on the other side. So if we wanted to be consistent, the way we would really write it would be 0.5 times a cubed. Excuse me, this should be 0.5 equals 9.5 times a cubed. Okay, so this is ending value, starting value, and this number here is difference in
Change of x to the x value.
difference in x for our case. A lot of times it'll be time. Okay, so let's solve this now. We divide both sides by 9.5. We get a cubed equals, I think I wrote it down somewhere. Yeah, 0.0526 dot dot dot, which means that a equals 0.0526 dot 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 to the power what? What should my power here be?
1/3.
Yeah, 1/3. The way I undo a power 3 is by doing a 1/3 power.
So that answer there is 0.5 divided by 9.5.
Yeah, this right here is 0.5 over 9.5. Yep, and so we get a is equal to 0.374756 dot dot dot. Okay. So we figured out what a was. And now we're given these 2 points. We have a. So let's write down what we know so far. We know y equals y naught, which we haven't figured out yet, times 0.374756 to the power x. Okay. So we want to take this equation. We want to know what y naught is. We want y naught. Right now we have an equation in 3 unknowns, so we can't solve it. But if we could fill in information for what an x value is and what a y value is, then we'd be able to solve this equation for y naught. And we know about 2 points which satisfy this equation. We have -2, 9.5 and 1, 0.5. So I'm going to take this 1, 0.5 all the way down here, and I'm going to plug it in. Why did I choose 1 and 0.5 and not the other point? I don't know. I just like powers of 1 more than I like powers of -2. But you can do either one and it'll still work. So I plug this point in. My y value should be 0.5 equals y naught times 0.374756 to the power what? What should the power be? Or what I'm really plugging in here is this point right here. The y value was 0.5. What's the x value? 1. So to the power 1. What's 0.374756 to the power 1? Yeah, just itself. Anything to the power 1 is just itself. Okay, so how do we figure out y naught? We just divide both sides. Y naught equals 0.5 divided by 0.374756, and I didn't calculate that. Okay, so that's the second step here. So everything beneath this red line is step 2. Okay, I took my equation, and now that I know A, so the critical step here was figuring out A so that I could plug it in here where I am highlighting in blue. If I didn't have A, then I would have one equation where two things are unknown, and I wouldn't be able to solve it explicitly. I need, if I have one unknown, I need one equation to solve it uniquely. If I have two unknowns, I need two equations to solve it uniquely. 3 unknowns, 3 equations, so on and so forth. Okay, how do we feel about that problem? A little bit better? You guys want to go on with something else, or try another one of those graphing problems? There's a lot of extra problems here. We could choose one. Okay, let's do one more problem. We'll do problem number 7. Let me erase all this garbage. And right. Okay, suppose a city has a population of 400,000 at time t equals 0. Okay, bam, P0 equals 400,000. All right, where t is the number of years after 1990. If the city's population decreases by 2,500 people per year, find a formula for P of t, the city's population t, years after 1990. Who wants to do it for me? Is this exponential decay? No, it's not.
Increased by 2,500 each year.
So what do we call that?
Linear.
Linear. So this should be an equation of a line.
400,000 minus 2,500 or t.
Exactly.
Using years since 1990 or after.
Exactly. Okay, that one was easy. Let's do B. The city's population decreases by 6% each year. Aha, now we're exponential, right? What does this tell me? If decreases by 6%, how can I interpret that algebraically? Yep, Ryan?
Your A is going to be 0.94.
Yes. In particular, R is negative 0.06. So A equals 1 plus R. Since R is negative 0.06, we get 0.94. Exactly right. Okay, what about P naught? P naught's the same, right? So we have P naught and we have A. What's the equation going to be? P of t equals what?
Isn't it still 400,000?
We're going to have 400,000. Now what?
Just times 0.94 to the power of t.
Exactly. That's our equation. Okay. The other two of you okay with that? How we found that?
Yeah.
We just used the formula P of t equals P naught A to the power t. We figured out what P naught was automatically from the problem. It told us starting population, 400K. A, Ryan helped us figure out using this decreases by 6%. That tells us R should be minus 0.06. A should be 1 plus R. We figured out what A was. After that, it was just a matter of plugging into this formula. Okay, that was a quick one. We'll do one more. All right, there's no more of those finding the things other than this one right here. Do you want to do this one?
Yeah.
All right. Oh, what? That didn't work. Maybe it's because I accidentally clipped some of the drawing. There we go. All right, so who can give me my 2 points? Zero 32. My other point?
2 and 2.5.
All right, you guys walk me through what I should do.
So, trying to find A that begins here, starting value of 32, set it equal to, it's your starting value times A raised to 2 equals our ending value, 9.
All right, you two, do we agree?
So wait, why is it squared instead of cubed?
Good question. Ryan, can you answer?
Yeah, because the difference between the 2 points, x values, is 2 instead of 3.
Exactly. So from here, I go, here's 1, multiply by A to get this far, to get this value here. Multiply by A again to get this one up here. Okay, so that's why it's 2 this time, is because this number that goes here should be the change in distance on the horizontal axis. Okay, so we're exactly right. So let's do it. We get A squared equals 92.5 over 32. Then we take the square root of both sides. We get A equals square root 92.5 over 32. Okay, wonderful. So we found A. How do we figure out why not? Two ways we can do it.
Put A in the equation and then plug in a 1.
Yep, it's way number 1. So, first of all, what should my equation be so far? How can I write it?
Y equals y0 times, be the square root of 92.5 over 32 raised to the power of x.
Exactly right. Now, we can take this point here and plug it in. We get 92.5 equals y naught times the square root of 92.5 over 32 to the power 2. So square root and a square undo one another. Y naught is going to be equal to 92.5 times 32 over 92.5 equals 32. So that's my y naught. You know how else we could have figured out y naught? Look at the graph. We know what y is when x is equal to 0, right? It's 32. All right, so that's one way we can check our work. Okay, so we used step 2 to figure out our y naught, but we could have also read it from the graph. I think it's good practice to do step 2 and figure it out using this formula, because in particular, writing this thing down, that's what I've kind of been giving you guys so far in class, and doing it independently, that's what will help you learn. Okay, any lingering questions about?
And the final equation would be like y equals 32 times a, right?
Times the square root of 92.5 over 32 to the power x. All right. More questions? Okay.
That was very helpful. Thank you.
Yep, I think we'll call it for today.